So my name is Anita, and I'm speaking with Dave. And the topic of our talk, oh, sorry, I'm not on yet. Turn on. How about that? Is that better? There we go. Okay, sorry. My name is Anita, and I'm speaking with Dave. The topic of our talk is using SaltStack for event-driven orchestration of OpenStack infrastructure components, which is kind of a long title. So I'm hoping that we can clear up different parts of that so we all know what we're talking about. And because we're such a nice small group, I'm looking for feedback from you in terms of making sure that you get what you want from the talk. So if we're not giving that to you, then speak up so we can make sure that you're getting what you want. First of all, introductions. I'm with HP, and Dave is with SaltStack. And I work on upstream OpenStack 100% of the time. I'm a member of the OpenStack infrastructure team. We'll get to what that means in just a minute. And HP sends me paychecks. And Dave does all the Salt things. And I made this slide, and I just put in the place headers, and he said, yeah, we'll just go with that. So
actually, it fits really well.
Does it? Yeah. Okay, all right. So for those of you who work with Dave, that is a good description and introduction for him. So in terms of OpenStack infrastructure, what the purpose of the OpenStack infrastructure team is providing automated service for OpenStack development. So I was talking to somebody who also works with HP, and he works on the deployment side. So he's actually setting up the HP cloud, which runs OpenStack underneath. And he was saying to me that the word infrastructure to him means actually what it takes in order to deploy a cloud. In the context that I'm talking about, the infrastructure team is responsible for setting up all the automated services so that developers can develop, so that they have all the communication tools that they need, and that they can get reviews for their code and submit and merge code. So infrastructure takes care of the creation and hosting of all the Git repos, the automated check and gate testing. How many people are familiar with the OpenStack development process at all? 2, okay. I'm just going to take a minute, 2.5, 3.5. I'm just going to take a minute. The way our infrastructure works, actually, I've got a graphic for that, so I'll cover that. But anyway, we also do the check and gate testing. We do communication tools. We do Etherpad mailing lists, asterisk. So we have to run all the servers and maintain them and also bring up new things if we need new services. So looking at the components, we run a Garrett. We run a tool called Zool, which was written by one of our infrastructure team developers. We started out with 1 Jenkins, then we moved to 3. We were 5 the first week of January, and last week we moved to 8. So we're now 8 Jenkinses. We have a tool called NodePool, which again was written in-house, and some glue from Gearman. So we'll see that in the graphic. So pretty wild graphic. So if I go over here, just in terms of our flow, if you're a contributor and you're contributing code, you submit your patch up to Garrett. Garrett produces a stream of events. Zool listens to the stream of events, and it triggers various jobs based upon what the type of event is. We had to use a Gearman and Gearman workers in order to go to multiple Jenkinses. So Zool talks to Gearman, Gearman talks to the Gearman workers, the Gearman worker talks to its individual Jenkins. Jenkins was not meant to be scaled out. And I also see our AV person has run away, so I'm not sure if the camera is catching this or not. So it is. Okay, great. The Jenkins, each Jenkins thinks they are the only Jenkins. NodePool is a tool to have VMs. The stars are all VMs. So node pool is a tool to ensure that there are VMs standing by for each of the Jenkinses. So it monitors how many standby VMs are for each Jenkins and has them ready and available. And then when Jenkins gets a message to run a job, then it goes to its pool of VMs, it selects one, runs the job, and then takes the message back to Garrett. The logs get stored on a log server, which isn't represented here, and node pool destroys that VM and brings up another one. So at the time I made the graphic, we only had 3 Jenkinses, but it's just add 5 more. So that's what that looks like. In terms of, I've lost my train of thought. I was going to talk about something, and I've lost my train of thought. And if it comes back, I will come back. Does anybody have any questions about this? Okay.
So what does Zool do?
What does Zool do? Zool listens to the Garrett stream. It is a communication layer between Garrett and Jenkins. It listens to the Garrett stream, and it makes decisions and sets up the information that Jenkins needs to actually run the job. So Zool is kind of the coordinator. Oh, I was going to talk about our testing. We have check testing and gate testing. So check testing is every time there's a new patch set to Garrett, it runs a set of tests called check tests. And check tests are run by themselves so they don't impact any other code. And then the logs come back how that patch did with that set of tests. Gate testing, and this is where Zool really shines. Gate tests, we have to run all of the tests, all of the patches in a sequence. And so Zool figures out the order of how it's going to run all of them, and then it runs the patches all together. It runs the test so that the 10th patch in the line is running on top of all the 9 patches ahead of it. So as soon as one of the patch fails, all of the tests for all the patches behind that have to run again, because any failure could be attributed to the failure ahead of it. So what it may mean is the worst case scenario is we only merge 1 patch at a time. Best case scenario, we have had 10 and 12 patches merge at a time if everything works out well. The other thing that the person who wrote Zool wrote a function called the nearest non-failing item, which now has it so that when the tests are being run, Zool can recognize when a test is failing, and it can start to reschedule all the jobs below that. So Jenkins does a lot of coordination for the tests in the gate. So all of our code gets tested before it gets merged. So everything has to pass the check tests and the gate tests before it gets merged into master.
This is a major function of the infrastructure team for all the OpenStack projects. So Nova, Salometer, all those projects, everything goes through Garrett and passes through this process to be tested here. So this is something they spend a significant amount of time on to ensure quality.
I saw a question over there. Go ahead.
Was the original need for multiple Jenkins an organizational issue, or did your actual Jenkins master just have insufficient resources to do builds for all?
That's a good question, and I'm just going to repeat it for the audio recording. So the question was, what was the motivation for having more than 1 Jenkins? Did the original Jenkins, was this an organizational decision, or did the Jenkins have insufficient resources? And it was insufficient resources. 1 Jenkins by itself can handle probably about 180 VMs, and then it falls over. So right now, what we like to run at is 1 Jenkins for 100 VMs. So we have 2 companies that donate all of our VMs, and that's Rackspace and HP. And right now we have 750 VMs donated to us. So we have to run 8 Jenkinses in order for that ratio to be held. Does that make sense? Okay, thanks. Any other questions, Carlton?
What kind of hardware are those running on, and would just scaling the hardware have alleviated that? I'm just curious.
Sure. The question is, what kind of hardware are these running on? And my answer is I have no idea. Because everything that you see here is 100% run on VMs. everything's run on VMs. Garrett's run on a VM. All of our Jenkins is run on VM. Zool runs on a VM. Our generous donors contribute VMs to us, and we run everything on those VMs. So we don't deal with hardware at all. Okay, so we'll move on. So that previous graphic is fairly complicated, but this is a talk about salt. So
okay.
let's get into where's the salt.
So OpenStack approached us to help out with some problems that they're dealing with. So one thing this is a really good example of is how salt plays nicely on your infrastructure. So using salt is not an all or nothing question. So they're using salt for not exactly for their configuration management. So they've been using Puppet extensively for all their configurations. You can go on their Git repository and everything's done in all their Puppet manifests. In fact, they have a really great Puppet manifest for installing salt. So if you need that, it's on their Git repos. It's really pretty good. So salt integrates with Jenkins and also all the OpenStack infrastructure that they're using. So salt made really good sense for that. So on their Puppet master, we installed a Salt master. So we have Puppet master running on the same server, the Salt master, as well as a Salt minion. So the Salt master can configure itself and do things there as well.
So there's another picture of the graphic. When I wrote it, I ran out of space. So just imagine another server there on its own, and it's the Puppet master, Salt master, with a Salt minion on it as well.
Yep. So we have Salt minions running on their Puppet master server, like we said, all the Jenkins slaves. And there's also a dedicated Jenkins server that's they call the Salt trigger. And this Jenkins server, when all the tests pass, it uses Salt's event bus to send a message to the Salt master saying that this Git hash has passed all the tests and can be pushed into production. And we'll dive a little bit deeper into how that works. That's kind of the point part of the point of this class or this lab.
I'll just take a minute for context. The process that Dave is starting off describing, he'll talk about a few more steps. This is particularly about changes to our Puppet configuration. And so when there's a change to the Puppet configuration, then there's a message that comes back to Jenkins so that the test passed successfully.
Thank you. And so then on the Salt master, there's a reactor that's running. I'm sure some of you are familiar with the reactor. It's essentially a service that runs on the master that looks at the events that are coming across the Salt event bus and then does things accordingly. So when the reactor gets that message from the Jenkins server that this test passed, then it tells the Puppet master to update its Git clone. And when that's successful, then the reactor basically says saltstar puppet.run, and then that tells all the servers to go out, pull in, execute the new Puppet manifests that they get from the Puppet master. Yeah, so we'll go into the coordination. I think that's the let's continue on there.
So just a little bit about the OpenStack orchestration history in order to understand why we're taking a look at adding Salt into Puppet. When we first started automating this, we have used Puppet for automated configuration, and the reason is at the time the decision was made, there were two choices, Chef and Puppet, and the person who was the project lead for OpenStack Infra at the time, he's still with Infra. He's just handed off the baton to another teammate to be lead for a little while. He was only able to get Puppet to work, so we went with Puppet because we needed automation. And what happens is that Puppet triggers off of cron jobs. So the specific case that we were talking about just a minute ago with an update to the Puppet configuration, if we just go off of cron jobs, but we're all waiting for the Puppet config change to manifest out, we all sit there and we wait and we look at our, and then it goes up to the puppet master, and then we have to wait for another 15 minutes, and then it gets disseminated out. And we just move too quickly now in order to waste that half hour that it takes for everything to be changed in the system. So the time-based orchestration is no longer fitting for all of our use cases in all of our situations. We have to stay with Puppet just because we've got too much of it to change. But we have to recognize that there are things we can do by bringing in Salt in order to make the process, the parts that are painful, we can make them a little bit easier for us.
Okay, so we're moving to this event-based orchestration for all these things that they're doing here. So this provides a lot of things that as programmers you hear about, like separation of concerns, various things like that, and also it helps us to avoid programming our orchestration. So a bad example of programming orchestration is back in the day when you did everything in bash scripts. It's like SSH out to here and do that, and then go to the server here and do that. And that's just a recipe for disaster. It's not going to scale. It's very brittle, and it's very difficult to maintain. Separate all the concerns. So we're going to take a look at OpenStack's manage project script. So when the, I think we have this next thing. Okay. When a project user requests a new Git repo, they essentially run this Python script here. And it's, there's a whole bunch of functions. It does various things. We come down to the main. And did I pass it yet? No. Okay, so we're editing stuff, pushing the Garrett, syncing upstream. This is even longer than I remember. Okay, let me go back up. So there's a main function that comes in here. Found it. So we're already 530, I think probably 600 lines of code. Collecting all its arguments. We're getting environmental variables. Up above, this does various things. It connects with the Garrett server to register new Git repos that are available. It creates repos on their Garrett server. It clones those repos to GitHub and to git.openstack.org. And then quite a few other things, some bookkeeping to deal with Garrett and that type of thing. Well, the problem they're having is when they would try to automate this and execute this, it wouldn't actually work. So some of the functions would happen. So yeah, like I said, so they submit a patch to Garrett to create a new repo. And this is an example of what that looks like. And backwards here. So.
Is that okay? You want me to drive?
So here's the files that are modified. And then people can comment and and approve these things. But part of the problem, something that happened quite frequently is that they would go to look at it in Garrett, and there would be no repository. The history of the repos that are supposed to be pushed in wouldn't be there, because essentially what was happening is everything was being executed at one time, and then so things, dependencies weren't being executed in the correct order. So they would end up with the situation here where the repo appeared to be empty. So then they would send an infrastructure team member onto the server that execute that managed projects script by hand, and then it would work. And it would appear like this. Okay, so this is what should have happened in the first place. But because of latencies, waiting for events to happen, it didn't always work correctly. So, what's a solution? The event-based infrastructure is a solution to this issue. So how does Salt help with this situation? So there's two main things that Salt provides that can really make your infrastructure very intelligent and solve some of these timing issues. First is the Salt's event bus and Salt's reactor. So the Salt event bus is a communication bus that happens on the minions and also between the minions and the master. And on the minion side, you can actually call Salt call event fire master, and that'll send a message up to the master to be processed later. And so earlier, when we had the Jenkins example, we gave Jenkins passwordless pseudo rights to execute Salt call event.firemaster, and then it could send the events up. So basically, any user that's running as the same user as the Salt minion, which generally is root, can execute this. So if you have, in your infrastructure, if you have any other software or coordination software that's doing things on your servers, you can also make use of this event bus to send information through Salt, through its event bus there.
And that code is already in our configuration. So that code is already available to be enabled. We had to use Puppet in order to get it in. So that's something that we just have to deal with. That's a reality of our life. But that code is available.
So on the master, we have the Salt reactor. So the reactor is a process that runs on the master that sits there and watches the events coming through on the master, on the event bus. And the reactor matches tags to events. So each event that comes across has its data that you can send an arbitrary amount of data of whatever structure you need, and then also a tag. And we'll look at some examples of that. There's a script in the Salt repo where you can watch them yourself. So if you're not sure exactly what tags are coming through, you can run what's called the event listen script that's in the Salt Git repo, and you can see exactly what's happening. Salt uses this extensively internally, so lots of events will come through. You'll see things like Salt, minion ID, and then start. So that means a new minion just started up. When high states and other executions finish, they come up to the minion. So there's a lot of things you can do there to kind of watch what's happening on your infrastructure and then act accordingly. So, and you could even, like I said, send your custom events. So say you had a database server that you only wanted to have so many connections. Once it reached a certain number of connections, you could have it send a custom event up to the master saying, hey, I'm maxing out on my database connections, and then the master could then decide to do something else. So it matches on these tags. And then these tags then get mapped to SLS files, which we're all pretty familiar with, to do something. So we'll look at that. We'll jump out to our docs page. So in the master config, which by default is on SE Salt master on your master server, you have a reactor. I guess that'd be the top level config option. And then you have a list of, or I guess it would be a dictionary actually, of tags. So these tags are all namespace. So these are tags that you might see coming through that are Salt internal. So you should never start your own tags with Salt. So for example, here we have Salt, minion, star, start. So here we're globbing on the minion name. So if you had minion with an ID of foo, the tag coming through would be salt/minion/foo/start. And so when the master reactor saw this, it would come through and it would execute that SLS, and when that finished, it would execute this SLS. Here is a tag coming through from Salt Cloud. So what this is saying is Salt, the Salt Cloud namespace, that would be a minion ID, was destroyed. So Salt Cloud went out, killed a minion off your cloud provider, and then once we got notified that happened, we want to execute this SLS file. So maybe that deregisters that from some registry of some kind, or maybe you run some other execution once that's out, so you know that that minion is gone. So you can do basically anything you want here. So with this example, with OpenStack, we're going to have a series of these executions that happen in order as we get successful executions going through.
I think you just coined a new word, infrastack, which is,
What did I say?
I think you said infrastack.
Infrastack?
Which is interesting.
Sorry.
No. I think that's pretty good.
Okay, thank you. I'll have to write that down for posterity.
Absolutely.
So here's an image to kind of sort through this process that's happening. So a new repo is requested. So we have a new Garrett's request here. Then we create a Git repo, a blank Git repo here on Garrett. And then it'll import, if desired, a Git history from an external Git repo where the project was started. And there's a bunch of smaller, bookkeeping type of things that aren't really germane to the whole process, but just so you have an idea, there's various things that happen here. Then we will have, again, the repos will be cloned and mirrored out on GitHub and also git.openstack.org. And then once that's all finished and everything's successful, then the Garrett software itself will register the new repo so that it appears in the web interface that people can use. And then people can start cloning it, sending patches to it, and that type of thing. So how do we automate? What does that look like? Let me go back to this here. So what that'll mean is when you send a command out to create the repo, it will, when everything finishes successfully, the last item will be a event.firemaster with a tag saying that the Git repo was created successfully on the Garrett master. So then when it'll get that tag, it'll say, oh, great. So then this next step would be, oh, let's mirror this on GitHub. That comes back successful. OK, let's mirror this on git.openstack.org. When those finish, it'll send another event through the reactor system that would say, OK, we've, it could be, the mirrors are successfully done. Then we would look for that tag. And then the next item here could be, register this new Git repo with your Garrett instance. So now that it's available. And all through these processes, you could also notify some other web application that's keeping track so you can visually see where things are in this process. So that's kind of, so this, here we have just two or three things here, but we could have a whole list of basically cascading events that happen with their corresponding SLS files that let you eventually complete this whole task list, but they're all separate and you're using the whole power of Salt's data-centric infrastructure management. So what are some of the benefits of that? One, you have that separation of concerns. So instead of having one big Python file that you're going through and you're connecting to this server and connecting to that server and you're executing this, each logical function is in its own SLS file and isn't affected by other things that are going on. It also allows you to adapt to a variable infrastructure. So like Anita said, just not too long ago, they had 3 Jenkins servers, then they're up to 5, now they're up to 8. With this type of infrastructure, the way Salt can target and glob on server type, server role, server name, that type of thing, it wouldn't matter if you had 2 Jenkins servers or 8 or 50 down the road. You can, it's flexible and you won't have to worry about the infrastructure varying on you. Also, because things are split out in those special little small sections in each SLS file, domain experts in your group can take care of the parts that they're responsible for. So if you have a section that's dealing with a MySQL server, your MySQL expert can come in and she can get everything set up just right, and then everybody else can use this and it'll be executed correctly. But they won't have to go through and dive through that big, huge Python file and make sure you're not affecting other parts of this process. Yeah?
What event information is available to each SLS file that's invoked when the event is caught in the reactor?
Great question. So the question was, what information is available inside the SLS file? Let me show you an example on the reactor docs. So here's an example here. So we're using Jinja to templatize this file here. So we have, there's two bits of information that come back are data and ID. So data is a dictionary that includes a bunch of information, one of which is ID. I think you have the job ID that's in there, a bunch of information like that, as well as any data that you passed in yourself. So if you send a custom event, you could pass in any message pack serializable data structure. You can send a whole dictionary, a list of things. So if there's specific information that you need to pass on, you can send that through. So you could say, here's the SHA hash of a Git repo that you need, or here's a URL that corresponds to whatever you're going to be doing, or anything that makes sense. So there's some standard info that's there, as well as pretty much anything else that you want to put in there. Great question. So another thing here is each step is isolated from the other steps. So in that Python script there's a whole bunch of if statements. There's a bunch of different code paths that could happen depending upon varying situations, and you might update part of that, not realizing that depending on a different environmental variable or something, you might hit another code path that you didn't update correctly. So again, you're splitting out things, making them much more succinct and simple. Another great point about this too is that this process can be started or restarted at any point along the way. So say on the second step there was an issue and you had it set up so that the whole thing just stopped if there was an issue that ran into. So you had to actually manually go in or have another process go in and fix that issue that was there. Then you can start right from that point and have it continue on, and every other step didn't even know that there was an issue earlier on. So you can continue on that process, and you can also actually start early, later on in the process. So if you have a long process, but say you're bringing an existing VM already into this new environment, you could say start on step 4, pass in send the correct message, and then start lower on in the process. So you can still have the same executions, configs, and that type of thing applied, but not necessarily the initialization steps earlier on.
This actually is a really important part, particularly for the process, the managed scripts or the managed project process, because we have to have because we have to have 3 different locations all ready to receive and be available to us, and have the right authorization for each. In order for the whole thing to work, this is quite often a lot of why it falls over right now. And because the API might change on one of them, or one of them's not available for one reason, and then the whole process falls over. And so this particular point, the fact that it can be restarted at any point would be important for us.
Okay. Again, I kind of covered this already, but this makes it also very easily to modify a specific process. So if one of those steps, for example, we have the step of cloning or mirroring the Git repo on GitHub and git.openstack.org. Say they decided to also mirror it on another service or another server, it'd be very easy to go in and at that one point add that function within that reactor to add the additional Git repo. So again, it's very easy to find the specific spot, and also it's very succinct in how to do that. And again, the process is very clear. So as you saw scrolling down that big managed project Python file, You know, and Python is a very clear, pretty understandable language, but you know, that was pretty complex, and there were quite a few little code paths there that you know, increased the complexity. So the simpler your infrastructure is and is managed, the fewer bugs that crop up, fewer opportunities for issues to appear, and it makes it easier for humans to ensure that it's doing what you think it's doing.
The other point on that as well is the simpler the process is, the more likely a new contributor is able to come in and make a useful contribution.
Yeah, that's actually something that's kind of difficult with the OpenStack organization sometimes, is there's a lot going on, and so for, you know, I mean, even like when I was kind of onboarding, figuring out how everything works, and it takes a lot of hand-holding and description of how things work. Even to this day, you know, even some of the people that are always working with OpenStack don't know how everything works. So the simpler things are laid out, you know, obviously coworkers, other people involved with the infrastructure can make significant contributions to it there.
It's to the point now where we've just come to accept the fact that there's nobody within OpenStack who knows how everything works. It used to be that way, maybe even 8 months ago, but now it is growing so rapidly that we just accept the fact that there are parts of OpenStack that not everybody knows how everything works anymore. So we just have to ask people, or read the documentation, or read the code.
Yeah. So again, the reactor is being used by a lot of people for doing very interesting things. You know, automatic key acceptance, for in auto-scaling type environments, and a lot of different ways to you know, make their infrastructure more intelligent and make it so sometimes you don't have to get up at 3 in the morning when you get paged. You know, sometimes Salt can take care of some of these issues. So, does anybody have any questions, or does anybody have any experiences like to share using the reactor, that type of thing? Yeah, did you have a question?
I have a question about bugs. I know how awesome Salt's Eventbased and reactor is. I was just wondering if OpenStack is being looked at mCollective, which is supposed to have the same similar message bus architecture.
mCollector?
mCollective.
mCollective. It's entirely possible that somebody on the team has looked at it. I'm not familiar with that tool myself, but the team as a group likes to be aware of various tools so that they are under consideration, because we're constantly changing and expanding, and right now we're upgrading Garrett. We're taking a look at replacements for Jenkins, because at 8 Jenkinses, it's no longer, it's going to get us through where we need to be, but we're taking a look at what's the better tool to replace Jenkins. So if somebody hasn't, but you think we should?
No,
so
because it's very, you know,
yeah.
It has the same purpose in the Puppet infrastructure.
Okay.
So I have talked with some of the other core infrastructure people about that, and basically it came down to I don't know all the reasons, but some of the things I mentioned were just the architecture was kind of a non-starter. Having the DriverMQ, it added a whole bunch of other dependencies to the infrastructure that they just really didn't want to get into. Essentially, was what it was.
Yeah, the DriverMQ requirements always been a deal breaker for me.
Yeah.
Do you know which message queue they're backing Marconi with?
I'm sorry, I know very little about Marconi, other than it's currently looking to be incubated, and it comes up frequently at TC meetings. So in terms of the underlying technology of Marconi, all I can do is encourage you to join the channel and ask the question.
And they use Salt heavily in the Marconi team. So actually, yeah, Ozza Khan spoke today. Yeah, they're using Salt heavily on the back end. I mean, isn't Marconi itself the message queue? I mean, it's.
Well, I don't know if it's backed by Salt. It's a message queue as a service. So.
Yeah, none of the OpenStack projects are married to any single deployment tool.
Right.
We leave it up to the individual deployer to select their tool of choice. There's too many tools out there for OpenStack to say, you know, this is officially blessed and this one isn't.
Right.
We personally within the infrastructure team, which is where my perspective is, we use whatever gets the rabbit down the road, right? Because we have to just merge so many patches.
I believe it's actually the rackers that are involved with Marconi are using, the Rackspace employees that are involved with Marconi are using Salt to manage their Rackspace implementation of Marconi. So I imagine not everybody is, but.
I believe Cupid is the other, Cupid, the Apache one, is the other queuing that you can do in OpenStack.
Oh, okay.
Instead of Rapid.
Okay, interesting. I didn't know that. I hadn't heard of
It's
that.
not really exampled out.
Cool. Thank you. Okay. Any other questions? I think we're ending a little early.
I think we are. We're okay. We're 6 minutes, but that's all right. So thank you very much for your kind attention. There's our contact information. If you have any further questions for either one of us, please do get in touch. And I would like to say thank you to you, Dave, and to Carlton and everybody else involved with SaltStack, because I've had a really good time. I've been incredibly impressed at the organization, extremely impressed by the food and the amounts of food and variety. It's been fantastic, and I just wanted to say thank you to everybody involved with organizing the conference.
Thank you. And thank you all for coming. It's been a great conference. So.